Hey guys, we're looking at your CAASPP prep, specifically looking at statistics for this video. This is, again, two questions we're looking at that are from your CAASPP practice test, just the one that's online. So let's begin. All right, first one, again, the question numbers, don't ignore them. Ignore them. It's going to be different for every student based on what version you're looking at, what test you're looking at. Okay. So it says, click above the numbers to create a line plot for the given percent chances of rain in different cities. So they're giving us a bunch of data, blah, here's some numbers. They're just listing out all these numbers, and we want to make something called a line plot. This might sound scary, but I promise it's okay. We're gonna get through this. So literally all we're doing with a line plot is just giving us a visual representation of these different data points. Because right now, looking at all these numbers, we're just like, okay, what now? Right? Like, what does this mean? It's confusing. It's hard to look at. So it's painful to look at too for some of you to look at so many numbers. So this is just making a visual for us. So what this is just going to be a bunch of dots, or I think for the CAASPP, it will, when you click on a box, an X pops up, so we'll just stick with that. So there are two 65s, so 1 and 2, and I'm going to cross them out as we go to keep us on track. If you were in the testing, there is a highlighter tool, so I encourage you to highlight as you go to make note of, okay, I've already recorded this one, so we don't document something twice or we don't miss anything. Then, right, you get marked down. For 70, there are two 70s, 1, 2. There are 1, 2, 3, 4 80s. So 1, 2, 3, 4 80s. 1 85. 1, 2, 3 95s. 1, 2, 3, and 1 100s. These are all percent chances of rain in different cities, and that's it. That's what we would submit. So now looking at this data as a visual, we could notice, right? Oh my goodness, there were a lot of 80s, right? That's going to be our mode, the most frequently shown value, right? We can also see there's quite a bit of 95s, but just kind of observe it. It's a little bit easier to observe when we have a visual, but they don't ask us to interpret it. That's it, and then you would submit. All right. Looking at our next one, this one is a little bit trickier, but nothing, again, we can't handle. So it says Michael took 12 tests in his math class. So 12 tests, his lowest test score was 78, his highest test score was 98, and on the 13th test he earned a 64. State whether the value of each statistic for his test scores, if it increased, decreased, or could not be determined when the last test score was added to this data. Okay, so we're going to start by just kind of making note here. So there are 12 tests. That is the total. And then there's a 13th hidden. So I'm just going to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then the 13th that he did. Okay, so 12 tests, his lowest test score was 78, and his absolute highest was a 98, but on his 13th attempt, he scored a 64. So he has a new lowest score, right? So this is, I guess it's kind of nice too as a visual. So this is what we're looking at for the data. We're going to be comparing this with, now that we add this lower score, how is that going to change the standard deviation, the median, and the mean? Okay, we're going to circle back to standard deviation. Let's just quickly recap median and mean. So remember, median kind of sounds like middle. We're talking about the middle number, the number that is, I kid you not, dead center in the middle of the data. So there were 12. So in the dead center middle would be 12, not 6. Yeah, 6, right? Oh my gosh. 12 divided by 2 is 6. My brain, I can't. All right, so we can even count it out. Okay, so 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6. So this was the old median. This was the middle. But now that we're adding another data point, Now there are 13. So 13 divided by 2 should be, I want to say 5.5. Let's check. I don't know how to bring that back, so we're flying solo without the visual, without myself in it. All right, let's see. So 13 divided by 2, halfway is 6.5. All right, so now that we add another data set, we could, even if we're not sure, we could check. Okay, so 1 and 1, 2 and 2, I'm just making a little mark in the corner, 3 and 3, 4 and 4, 5 and 5, 6 and 6, and 7 this would be the middle. Let me double check that, because it should have been 6.5. Let me double check. Please hold. This is good. Good stopping point. Okay, so let me just count out. So 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. Okay. And this has been a 1, 7. Yeah, the 7. So in the middle, dead center, there are 6 on either side. Yeah, sorry, had to clarify that. It's in the dead center. Let me double check. 2 for the old ones, just looking at the 12 and 12. So 1 and 1, I'm just going to do it with my finger. So 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5. Oh, that's right. Okay, so I was going to say that it should have been changed. This is why we check. This is why we double check our work. So the middle, I said, was here for the old version, but it's actually going to be, it should be here in between. So it should split up into 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6 equal segments. So this was the old median. Sorry about that. But, again, error analysis, we do it all the time, right? If something doesn't make sense or we're just double checking, this is, if anything from this video, it's reminding us the importance of checking our work. All right, so this is the old median, the old middle value, because again, it's dead center between what's in the green box. 1, 2, 3, 4, 5, 6 values. 6 test scores are to the left. 1, 2, 3, 4, 5, 6 are to the right, right? It's in the dead center in between these two. But now that we add another value, right, what's happening to that middle value? So now that we're adding another one, now what's the new middle? It should be here, because there's 1, 2, 3, 4, 5, 6 to the left and 1, 2, 3, 4, 5, 6 to the right. So this was the old median. This is now the new median. Again, we don't even need those values. We can just put like a placeholder, a little card to remind us for these test scores. So what's happening? It looks like it would decrease. The new middle is going to go down. So for median, we would check it's decreased. It's gone down. Now for mean, not that it's like mean, it's evil or something. Mean is just meaning the middle. No, oh my gosh. Where did median? Mean is meaning the average. All right, and how we find the average is we're going to take all of the numbers and we're going to add them up and divide them by how many are there, all right, for that average value. So we're going to take all of these numbers, add them up, divide them by something to find the average. Okay, in this case, we are not given every single value, so it's going to be kind of hard to determine exactly what's happening, but we could kind of give like just an estimate based on what they did give us. Again, comparing the old to the new. So let's compare that for old and new average. So again, we add the numbers, divide them by 2. So let's look at the old is just comparing the two extremes, 78 and 98 is 176. 176 divided by 2, just kind of see. Okay, so like an old, this is definitely not what it is, because again, we don't have all the values, but just to kind of get some sort of a visual, we're working with what we got. And now if we add that 64 to it, let's see what happens. So 78 plus 98, but now we're adding 64, and now there are 3 values. So now 240 divided by 3. So now the new is going to be 80. which makes sense because remember the average is like kind of like the middle number. It's the in between. If we're bringing in a number that is very, very small, right? This is much smaller than the smallest data before. This is almost like an outlier at this point. It's now going to lower the average, right? The mean is going to decrease. It's going to go down. That number is going to decrease because we're bringing in a value that's very small. Now, if they told us on his 13th test, he scored a number that was in between these two values, the two extremes, then we could not determine the mean if it was a number in between, because that, right, was it a little bit larger? Was like, we would need, it might be a little bit trickier to understand, but because they gave us an outlier, a significantly smaller number, like it's easier to see, okay, this new average is going to get smaller because now we're adding a smaller number to the mix. Okay, so median is the middle, dead center. Mean, we add up all the numbers, divide by how many there are. And then for standard deviation, I wanted us to look at one of my favorite websites, Math is Fun. Just kind of outlining what the heck is happening here. What is standard deviation? What's going on? There we go. And I was able to bring back my camera, so that's pretty cool too. I don't know how to move it, but it's fun. So standard deviation is the measure, of how spread out numbers are. And to find it, we use something called the variance, but they're not even asking us to find the standard deviation. I'm just going to kind of briefly in this video, what even is it? What's going on? So you got this example here with different dog heights in millimeters. So we've got 1, 2, 3, 4, 5 different dogs, and we measured their heights, and we drew it on this picture graph, which again is not greatest. We don't like having pictures on graphs, but I mean, it's cool, but for math, it's not great. Anyways, we're comparing the different heights of the dogs. Cool. Based on their shoulder heights, where their shoulder heights are. So if we want to find the standard deviation, we need to know the mean. So the mean, remember, this is the average. So we add up all the numbers, divide by how many there are. Okay, so we've got this like baseline. Okay, this is the average, but standard deviation kind of is helping us find like the standard, like what's normal, what would be a normal height. So to do that, we use that mean, and we're seeing what's the difference between each dog's height and that average. What is that difference? How large or small the difference is there? We square them up and take that average, divide it again by how many there are, so like 5. And that gives us, in this example, the variance, 21,000. We use that, we square root it to get the standard deviation. Now, again, these are just words right now. This might not be making much sense, and that's okay. So standard deviation, this is the distance from the average that is considered standard, that's considered normal. In this visual, it's helpful for us because now we could see like the Rottweiler is extremely large, right? It's much taller than the average and even the standard deviation. And this is showing 2 standard deviations, which I think they show a little bell curve. Yeah, bell curve. So within 1 standard deviation, 68% of our data points are going to be under that bell curve. This is like another graph, another visual of this. Between these 2 standard deviations, 95% of our data points are in that region. So what that tells us is when we find the standard deviation, again, this is the majority, this is the standard, what's considered kind of normal. Based on all this data we've collected, this is like, we've got the average, the in-between average, and then we have what's normal, what's that range of what's considered normal. So again, we can see the Rottweiler is above that. It's extremely tall versus the Dachshund. I think that's how you pronounce the name. Yeah, if I'm mispronouncing it, I'm so sorry. Is considered much smaller. Okay. So again, standard deviation. All right. So using this as an example, let's say we took off, I don't know why I chose, we'll just call it a corgi because it's going to be like easier for me to pronounce. we'll say it's a corgi, and let's say, right, because since that's the smallest, let's use this as an example. So let's find what would the standard deviation be if we did not include the we'll call it a corgi for now, versus again comparing this answer they gave us with the corgi. So we can kind of use this as a reference point to help us with that last problem. Okay, so we are going to look at the variance, and all we're doing is, so for the corgi, wink wink, negative 224, so that was this value here, this 50,176. We want to remove that. We're going to add up the other four values and find the average divided by then 4. I think I've got a calculator over here so we can check. Actually, I'll just use the Desmos calculator. I like Desmos calculators. They're nice. Maybe not, because then I have to figure out how to get rid of my camera. Okay, so let me clear. I'm going to add everything except that value. So 4, 2, 4. I can pause. It's going to take a while. All right, there we go. So we've got all of those data points added up. That gives us this very large number. And we're going to take that and divide it by 4, because now we have a new average. I, again, removed the corgi from the mix. We're looking at, without the corgi, what's happening. That gives us our variance. But to find the standard deviation, we need to take the square root of that. So square root of 14586 is going to give us 120. So what that would show on our graph here is if we removed the corgi, this distance would be, hold on. So if we removed the corgi, then this distance is going to be less, right? Because before the standard deviation with the corgi, with that extreme outlier small value, it's growing. It's now, because we're adding more range, right? We're adding a smaller value. So it's going to expand the standard deviation versus before, without the corgi, instead of 147 millimeters in each direction, it would be just 120. So that's like a lot less, like 27 less. So when we do add a smaller value or a larger value, it's going to expand that standard deviation. It's going to stretch it out more. Again, versus if we had a value that was within the standard deviation and we're adding to it, it might not change very much. It might be a little harder to determine. All right. We still could kind of give an estimate based on where it's at with the mean. Okay, so jumping back to this problem here. So we're asked what's happening to the standard deviation. So because we are adding this very tiny value, right, with that visual of the dog standard deviation, because we're adding a small like outlier, the standard deviation is going to increase. We're adding more information. We're adding more of a range, wider range of what is considered normal because of this very small value again. Okay. I hope that makes sense. I hope this video makes sense. As always, if it does not, please let me know. But we're just kind of, again, gearing up, we're preparing for upcoming state testing. And yeah, that's it. All right. Bye, guys. Take care.